comparators. Comparators, right? See here, suppose A is of 4 bits and B is of 4 bits. Okay, next concept will be like cascading comparators. Okay, A is of 4 bits, for example, B is of 4 bits, like 1 0 0 1. Okay, 0 1 0 0. Let us consider. Okay, A is of 4 bits and B is of 4 bits. Now, if you see here, this is your A 0th position, A 1th position, 2th position, and 3rd position. A3 is compared with B3. See here, A3 is compared with B3. Okay, if suppose if A3 is greater than B3, what happens? As A3 is greater than B3, directly it will be telling that A is greater than B. Okay, see here, what is its value? 8421, that means its value is 9. What is its value? 8421, that is nothing but 4. See, 9 is greater than 4, so directly it will be telling its value. That means it will be checking its your MSB value. If you check your MSB value, you can tell it. As if A3 is greater than B3, then directly you can tell that A is greater than B. Okay, consider another one more example. 0 0 1 1 0 0 1 0. Consider here. See here, A3 is equivalent to B3. Yes, both are equal. Then you should go for the next higher order bits, next lower order bits. Next, again it will check A2 and B2 are equal. Yes, both are equal. Next, you should go for next lower order bits. Again, these two are lower. Again, you will be going for next lower order bits. Again, you find, see here, this is 1 and 0. That means A is greater than B. Okay, if you see, this is your 3, this is your 2. So A is greater than B. That means what is main concept is that it will be checking. So when it will be checking for the next one, if it finds it's equal, if at all if it is equal, then only it will check the remaining bits. If at all it is not equal, what happens? Then only it will be telling that whether A is greater than B or A is less than B. Okay, if suppose you find it out A is greater than B or A is equivalent to B, if these two conditions are not satisfying, itself says that A is less than B. Okay, right? Now we'll be seeing your 64-bit comparator. Have to do that. See here. See, like A is of 64 bits and B is of 64 bits, right? That means, see here, A value is ranging from 64, like A0, A1, A2, so on up to A64, A63. That means 1 0 0 1 0, so on up to some 0 values. And B is of 64 bits. Okay, again it will check 0 1 0 1 0 0 something, so on up to this. So if you want to compare it, how you are going to compare? Okay, that means an IC should have all 64 pins. A is of 64 pins and B is of 64 pins. That means total 128 inputs should be given. So it has to check and it has to provide whether A is greater than B or A is less than B or A is equivalent to B. Is it possible? That is quite complex. So you are going for cascading. That means you will be taking some ICs. See here. You will be considering your 8 inputs. Okay, 74 by 682 is your 8-bit comparator. Okay, that means it will be taking your P and Q values. P and Q are your inputs. P is of 8 bits and Q is of 8 bits. That is P 0 to 7 and Q 0 to 7. See here, this is your cascading comparators. If you see here, if you see see here, this is EQ2. If these both the pins are equal, that means, as I have said earlier, that means it is starts checking from P23 to P0, again from Q23 to Q0. Okay, now I have been splitting into 4, something like that. So first it will check for the highest order 8 bits, like P8 bits is compared with Q8 bits. Okay, if both are equal, then it will go for the next higher order 8 bits. Okay, if these two are equal, then it will go for the next higher order 8 bits. If these two are equal, then it will go for higher order 8 bits. So here similarly, see here, P16 to P23, that means P23 to P16 as well as Q23 to Q16, it will check. Okay, if higher order bits are checked, okay, they found they are equal, okay, then it will go for the next higher order bits. That means here, again it will check from P8 to P15 and Q8 to Q15. That means this one. It will check for the next higher order bits. If they found equal, what happens? If at all they is found equal, then only it will check for the next higher order bits. If at all they found that P is greater than Q, it will give like P is greater than Q. If it all found that P is less than Q, it will give P is less than Q. Similarly, so these are equal. As these higher order bits are equal, next it checks for the next higher order bits, like P8 to P15. Okay, next higher order bits it will check P8 to P15 and Q8 to Q15. If at all these are also found equal, okay, these are also found equal, what happens? It will check for the next 8 bits. Next 8 bits means P0 to P7 and Q0 to Q7. Okay, so again it will find equal. That means when P is equivalent to Q, if Q2 is Q2, EQ of 2 as EQ of 1 and EQ of 0 both are equal, then only we can say that P is equivalent to Q. Even one bit change, we can say that whether P is greater than or less than. If all the bits has to be equal, then only we can say that P is equivalent to Q. So similarly, if P16 to P23, like here higher order bits are equal, yes, higher order bits are equal. Again it will check for the next 8 bits. Yes, next 8 bits were equal. Okay, again it will go for the next lower 8 bits. Yes, they are equal. Then only it will tell that P is equivalent to Q. Okay. Similarly, how to find for greater than? How to find it for greater than? See here, what I have said, like P23 and Q23, so on up to P0 to Q0. Okay. See here, it will check for the 8 bits. These 8 bits, it will check P8 bits and Q8 bits are compared with each other. If at all they found that they are greater, okay, if at all they found that they are greater, that means P16 to P23, Q16 to Q23 are compared, they found they are greater, yes, G2 is greater, then A is greater than B. You can tell that A is greater than B, or P is greater than Q, or P is less than Q, right? P is greater than Q. Similarly, if suppose P is not greater than, that means these are equal. Suppose they are equal, okay, that means EQ2 is there, that means EQ2 is 1. They have found that they are equal. What happens? It will check for the next highest, next lower priority, that they'll found out here. Okay, they'll found out here. Again, if it is greater than, if GT1, that means they found here it is greater than, then also P is greater than Q. Okay, here also they found that they are equal, That means place EQ2, here they are equal. Again they checked here, here also they are equal. Okay, EQ1, here they found that they are equal, they are greater than, that is GT naught. So either if G2, if this is greater than, P is greater than T, I can get greater than, yes. See, I am checking only for greater than. Okay, if P16 to P23 is greater, I will be getting greater than. If at all I get equal to here, if at all I get equal to 2 here, then I should check for next higher order bits. If I get GT1, then also greater than. Okay, if these two are equals, then I should go for the next lower order bits. If this is greater, then also it is like greater. So like that. Now we'll see how like comparator like 24 bits, how they are going to compare its VHDL code. Right. See, now I'm taking like P and Q are your inputs. Right. You will be finding out greater than output and equal to output. If you see that IC, it is like taking P and Q as your inputs. Okay, greater than and equal to are your outputs. If these two outputs are not satisfying, then it is similarly like P is less than Q. Okay, so greater than and equal to are your outputs. Begin. If equal to is equal into 1, if both the bits are equal, if equal to pin is equal into 1, so if you take this IC, P is ranging like 23 bits, Q is ranging from 23 bits. You have two outputs, right? Equal to output as well as greater than output. If equal to output is equivalent to 1, what it tells? P and Q are equal. Sorry, I have wrote here A and B. P and Q are equal. Okay, if greater than pin is equivalent to 1, what indicates that? P is greater than Q. Okay, else 0 and comparator. From this we have come across your comparator.